Welcome back. This is the PLTW's hydrogen fuel cell. This is not really anything uh, information that you'll be tested on, but this will be information to help you build your hydrogen fuel cell cars and your hydrogen fuel cell objects that you will be seeing here in the future. So let's go on. First off, we got to look at the trends of the type of fuels. Currently, wood, coal, oil, natural gas, they progressively have more hydrogen, while hydrogen itself is nothing but 100% hydrogen fuel. So that idea is that we can take those objects, and if we can take that hydrogen and burn it, we can produce more power. Now, in the 19th century, we used steam, and in the 20th century, we used internal combustion. The 21st century and the future, we're hoping to use more like fuel cells. How a fuel cell works is this. You take electricity and you pump, you have electrodes here and here, little pieces of metal, and you electrocute the water. Now you'll separate oxygen here and hydrogen here. Now, if you take that same one and replace the battery with a device, let's say a light bulb, then the hydrogen and oxygen will actually recombine, producing electricity to come back. It's a lot more fancier version, so this is the first kind of fuel cell that they had. And here's some other, this one's on the space shuttle fuel cell. And here's some cars that run off of fuel cells. So these are cars that actually use water as fuel. Here's an actual real giant one that works on a building. And here's a smaller one that you can power your own personal house. Here's a smaller one that can actually power a light bulb. So these are all the different types of fuel cells. We're going to use one in class. Now, this is how it works. This is the chemistry. Hydrogen will become hydrogen ion and produce electrons. And then the cathode or this side will take the oxygen, add on the electrons from the hydrogen, and make water. So you're just taking hydrogen plus oxygen, making H2O, and this produces lots of energy. And then that energy comes in. So here's what our fuel cell is going to look like. So, and this is kind of some ideas also of how it works. If you're really interested into the chemistry of this, this is some really great fun chemistry. Again, here's some more AP Chem level stuff. You can see that the power and that is going up, and it continues going. Now, here we go. If I can compress at 200 bars of pressure, 56 liters compared to liquid hydrogen, which is at 14, and then a metallic hydrogen, which is 9.9. This is how much you can compress it in. So here's how it works. You take the fuel cell, you reform it, you produce hydrogen. Then, or solar power uses electricity, electrocutes the water, produces it. Or there are some algae they're working on to produce the hydrogen. Then you take that hydrogen, put it in your car, your house, whatever, and that produces the electricity that you needed. Now, the reason you do this is because it's clean, it's very quiet, it's extremely safe, efficient, it's sustainable, and you can move it around modular. It is safe in that if you put it in a certain system, you won't blow up like a lot of people think. And this is the reason why we care so much about this. Our planet is very fragile, and we do not want to generate too much carbon dioxide to cause the greenhouse effect happen even more. Whether or not the greenhouse effect is happening, that's a whole different debate. But this way, we can take that 75% of all that water that's on the Earth and use that as a power. So if you have any questions, ask your teacher.